Haha, I had to shrink the text to make this fit, isn't it great? Yeah, space-time geometry. Yay. This is not going to confuse me at all. And here's a disclaimer. Isn't this fun? Alright, so one thing I want to make clear before I even get into this. Space, in terms of what we can actually move in, is 3D. However, you'll see me a lot of time explaining space as a line, or if I'm feeling less lazy, as a grid. And it's really actually not about laziness as much as I like to make self-depreciating jokes, but it's easier to comprehend that way. But you kind of have to imagine how that works on a larger 3D scale. Another thing I want to say, space isn't actually 3D in and of itself. It's actually 4D. Because, and likely even more, because even though we have the 3 dimensions that we see and interact with, space-time itself has to bend and move in different ways that aren't really allowed by 3D space, so that everything can work properly and seem well. For example, wormholes, you have kind of 2 planes of space-time. And again, by plane I mean not a plane, I mean like a cube or whatever else shapes it has. A wormhole connects 2 things. So how does it have to do that? It goes around. Now, this is a 1D representation that's now 2D. So if we were to have a 3D representation, this would then have to curve in some 4th dimension and, do its thing essentially for that to work. So again, a lot of times you'll see me turning 1D interpretations into 2D interpretations, and you read that as a 3D space going up into another dimension, to a 4th dimension. And really, it would be impossible to explain this using the proper dimensions, because, well, we can't even see in 4D, let alone explain it and not have our minds melt. So, let's start with, what should we start with? Let's start with wormholes, since I was just talking about that. How do wormholes work? Well, it's pretty simple. It's essentially just a tunnel in space, like a worm's hole. So you have kind of 2 planes, and I'm making air quotes so you can't see, where an object can go along this plane, quotes, and go into this tunnel essentially, and come out the other side much quicker than you would going the normal way like this along our space-time. Oops. So yeah, think of it, if you've seen or read The Wrinkle in Time, it's the same basic concept, but actually scientifically accurate. I'm gonna get flamed for that. Anyway, point being, this goes and merges 2 points in space. Not merges, but it makes a tunnel between 2 points of space, in which you can travel through it very quickly and come out at some other place. In some cases, even at a different time. Though, for our purposes of UF, we assume that's just within space, because, again, if you've seen the RP Rules video, time travel gets complicated and no one wants to deal with that, really. So, that's wormholes. How about, what else can we talk about? Black holes. Black holes are, well, as the name implies, essentially holes in space. like this. They are objects with extreme amounts of mass, so much that, like, it may as well be an infinite amount. Though, realistically, it has to have some mass, so it only goes down so far. But, because of their nature, really, we can assume that the hole just goes down forever, and it would be a relatively safe assumption. Obviously, from conservation of matter and energy, we know that it has to go somewhere, but no one knows where. Anyway, so that's how black holes work. And again, on a 3D scale, those black holes are going down in some fourth dimension that gets represented as gravity. The fourth dimension affects our three-dimensional world in the way of gravity. And again, it can be more than 4 dimensions possibly, depending on how complicated the shape of the universe gets as wormholes form, black holes form. Really, anything with gravity, you're those 2D grids, and it shows you the stars and some 2D grid warping under it. Actually, hold on, I can probably find it on Google really quick. Yeah, here we go. So, this thing. Oh, wow, this is a really low quality image. Hold on. This might be better. Yeah, here we go. So, you see how this is going down and up and everything? So you can imagine this 2D grid is, again, it's an inaccurate representation. Really, this grid goes in 3 dimensions. It's a 3-dimensional grid. So these kind of dimples almost in space-time, those are, again, 4th dimension. Or, whatever else dimension there is, depending on where you are. But as far as a 3-dimensional being is concerned, this is a 4th dimension going down. And again, when I say 4th dimension, I mean geometric dimension. Obviously, we have time as our 4th dimension in realistically, but 4th geometric dimension, if that wasn't clear. So, and our kind of gravity and everything gets represented in this manner. So that's how we know, that's how we kind of detect almost this 4th dimension as gravity. That's how it affects our world. So, yeah, that's actually how gravity itself works at its core as well. And then negative mass, you can imagine it works the opposite as this positive mass you can see here, where space almost makes a bubble. I have no way of really describing this on here, but it makes almost a bubble like this, where it pushes objects away from it, such that if our Earth was moving towards it, then it would get repelled instead of being dragged into some orbit. Wow, this is fun, isn't it? Anyway. Yeah. Let's see, what else do I need to talk about? Really, that's it. I've touched on... What have I touched on? I've touched on normal mass objects. I've talked about wormholes, which tie into string theory, though not directly. And we've got negative mass objects, and we've got black holes. So yeah, that's everything. Though, one thing that I will talk about maybe as a separate video is how to take advantage of this. how to use this to... Actually, no. I'll talk about it right now. So, let's say you have some megastructure. Let's say it's a ring world. Alright, you have your star, you have your ring world. It's all fine and dandy. But, oh no, there's an issue. Your ring world is too big. Now it has its own gravity. Now what are you gonna do? Things are getting pushed into it. It's collapsing to a toroid shape. How do you counteract that? Well, if we take this, we know that positive mass pushes down, supposedly, on our fourth geometric dimension. So how do we push back up with negative mass? That's simple. So we need to just have points in which we're pulling this space-time back up so that there's essentially no gravity, or it's completely counteracted. I don't know, what have I done here? Okay, there we go. So, what we want to do is, what we'll do is, we will put some negative mass all around in here, just so that it maintains its integrity and stays together. Most likely, if you're able to do this, you've already got artificial gravity, so you can figure that out as you go. But if we put negative mass generators all around it, this way, this does two things. A, it maintains the integrity of this structure. Now, it's not going to collapse into a toroid like our... hold on. Let me get a picture of it. Like the amazing toroid Earth. Oh wow, this is a big picture. There we go. Like, now, this is great. Don't get me wrong. But I like my ring worlds as a ring. I don't know about you, that might just be me. I might just be weird. But that's how I like it. I like it to stay a ring world. So, because of that, and because of my pickiness, I'm gonna put negative mass all over here to make sure that it stays integrated. Another benefit of this is that if you do it in the right amount, you can actually keep and take advantage of some of your ring world's gravity, so that you have a little bit. You don't want to overdo it, because then obviously it'll collapse into itself and to torus Earth. But you can have a small amount of natural gravity. Now, it can't be a lot. Like, think about the size, about the same amount of gravity that a asteroid would have. Because asteroids, even though they're fairly large objects, they still don't collapse into spheroids or toroids. So, because of that, that's kind of the amount of gravity you want to shoot for. It's not a lot of gravity by any means, but it is still some gravity, and obviously if you're this advanced to make ring worlds and have negative mass, you're going to be able to make your own gravity within specified regions. But you want to be careful, otherwise, again, as I've said several times, you're going to collapse into a toroid, and that's no fun. So, that's how you take advantage of it in keeping your megastructures and everyday battle stations safe. Now, that's one way to take advantage of space-time geometry. What's another way? You know, it would be cool if we could drag ourselves across space-time. And that is what you would call spatial warp. Now, I've already seen some very good diagrams of this, so I'm just going to see if I can find a picture of it somewhere, or at least something that I can explain. Here we go. This is actually exactly what I was looking for. Here, it's not a very high quality image, but here we have our classic, 2D space-time image. Okay, and you can see how this works here. you have hold on, let me get a nice color here. And it says primary, don't I? Okay, here we go. So, we've got positive mass in front that's dragging our object forward into this gravity well, into this higher amount of gravity. And then in the back, we've got the opposite. We've got negative mass in the back. The negative mass is pushing it away from it, the negative mass. And the positive mass is pulling the object towards it. So you've got two sources of gravity pushing you along space-time. And because of this, because you are basically dragging yourself along space-time, the limits of going at light speed don't apply. Because within space-time, you're essentially stationary. And actually, if you're moving physically, that actually just adds to it, really. But you are never going past, technically, the speed of light. However, you are obviously still moving physically faster than the speed of light. You can move light years using this method. It does have its limits, and it's kind of hard sometimes to set it up properly. But for an earlier or newer nation, this is the best thing you can do. Because it's lets you travel really fast within, your neighboring stars and stuff. Very good for, inside systems. Within systems, it's good for larger empires where you're going across universes and stuff. This is good for within universes or within even systems to travel and just go about your daily commuter life, commuting from Earth to Mars, then shopping at the Jupiter Space Mall. I don't know. You get my point. But yeah, that's another way you can do it. Though, I would recommend for larger nations, I would say go for some wormhole tech or something, because it doesn't scale as well as some people would like it to. Doesn't scale as well as I would like it to. And again, it's up to you how you want to set up your nation, but that's, to me anyway, it doesn't scale well at for a larger nation. But yeah, those are two ways you can take advantage of spatial geometry, and that's also how spatial geometry actually works. Thank you for watching, and I will see you maybe, I don't know.